Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our second class in week 2 of classes. And just a reminder that if you didn't finish your PLAR English or PLAR History Geography in term 1A, you can continue working on it in this term. So you're not withdrawn from PLAR. Just continue working as the terms go by from wherever you left off. So it doesn't matter if the term ends or not, you just continue working on your key questions and submit them to your teacher. Just a reminder as well that there are 2 classes per week. So our classes are Tuesdays and Thursdays from 10 to 11 Central Standard Time. And 2 ways to participate in classes. You can participate on radio by calling into our studio, or you can participate using Zoom. And the link for, using Zoom and the instructions for joining a Zoom class are in your study guide, or you can contact your DEC or me for help with doing that. All PLAR students are welcome to attend classes, so it doesn't matter how you signed up for Radio Zoom, how you signed up for the PLAR classes, either IL or Radio Zoom. The classes are a tutorial, so any PLAR Math student is welcome to join the classes. To contact me, you can use email, phone, or send a message on Facebook, whatever works best for you. And if you have any questions about the PLAR Math or the PLAR English, please contact me so that I can help you with that and we can get you going on your way. The PLAR English classes from last term are still available on YouTube. 2 places on YouTube now, actually. So you can go to my YouTube page, B. Osman Wasa, and you'll find my playlist there, the PLAR Math and the PLAR English. PLAR English is from last term. The PLAR Math is from last year, except for the first few classes now, which I have updated with this year's classes. And we also have a WASA Distance Education Center YouTube channel now that you can go to, and you can have access to all of the courses, the Radio Zoom courses, classes that are offered in last term and this term. So all of those classes are available for you at the WASA Distance Education YouTube channel. Okay, so you can go there and you will find the PLAR Math from this term and the PLAR English from last term, as well as Jovi's PLAR History and Geography and the PLAR Science. Okay, so all of the classes that are offered on Radio Zoom are available for you on that WASA Distance Education YouTube channel. Okay, as I mentioned before, term 1B, we started last week, but term 1B will continue after the Christmas holidays. So seems like a long term, but it's still only 9 weeks. We have 6 weeks before the Christmas break and then 3 weeks after the Christmas break. So try to get as much work as you can done before the break, and that way you don't have to worry about catching up using your Christmas break to catch up. Okay, just a reminder that this year we started something new with PLAR students. So PLAR students can choose the option of writing the culminating activity, which is the test, instead of or before doing the lessons and the key questions. So if you want to challenge it, so if you feel confident about your skills in any of the 5 PLAR subjects, you can choose to write the test instead of doing the lessons and key questions. If you pass the test, then you will get your credits for that subject, and then you can just move on to the next subject. If for some reason you are not successful with the test or the culminating activity, then you will have to complete the lessons and the key questions, and then you get the chance to write the culminating activity again. So as I mentioned before, it's not a one and done thing. You do get a second chance to rate the culminating activity and a third chance if necessary, but hopefully not. Okay, so that is an option for you this year. Okay, in your lessons, if you're doing the lessons, you will notice that there are support questions and key questions. The support questions are the practice questions that you do before you do the key questions. The answers for the support questions can be found near the end of the lesson, right before the key questions. So once you do the support questions, then go to the end of the lesson, find that answers to the support questions, and check your answers against the answers that are there. If you are doing really well with the support questions, then you move on to the key questions. The key questions are the questions that you send out to me for marking, and you will notice that they have marks assigned to them, whereas the support questions do not. Key questions are all found at the end of the lesson, so you can just pull the key questions off from the rest of the lesson and send them out to me for marking. Don't wait, however, until you've finished all of the key questions for a lesson. Send them out to me as you do them. Okay, submitting your work. There are several ways to do that. The first way is to give it to your DEC, and your DEC will send it out to us here in Sioux Lookout. If you don't have a DEC, you don't have a learning center, or your DEC is away, then you can submit your own work. Several ways of doing that. If you have access to a scanner, then you can scan and email your work to studentwork@nnec.on.ca and make sure you CC it to me. Or if you have access to a fax machine, you can fax your work to our toll-free fax number. If you are submitting your own work, be sure to write your name, the subject, and the teacher's name on your work, okay? Make sure you include all that information so that when it comes out to us, we know who submitted it, and then your teacher knows who to return it to. Okay, so very important that you have your name on your work. Another way to submit your own work, if you don't have access to a scanner or fax machine, is to use your smartphone. With your smartphone, you can take photos of your work or scan your work, and then you can either email it to same address, studentwork@nnec.on.ca, and CC it to me, or you can take the pictures or the scan document and you can send it via Facebook Messenger. Okay, so whatever works better for you, trying to accommodate students' needs and the technology that's available in the North. If you are in Sioux Lookout, if you live in Sioux Lookout or the surrounding area and you come to Sioux Lookout fairly often, then you can drop your work off at WASA. You can either drop it in our mailbox that's in the parking lot, or you can drop it at the front door, knock on the door, and give it to whoever answers. The door is still locked, but there is usually someone at the front. So if you knock on the door, someone will answer the door and you can drop your work there. You can also use Google Docs. Do your work using Google Docs and then send me the link, share the link with me, and I can view your work that way. And then the last option is to use Google Classroom to complete and submit your work to me, so you can go paperless. We do have a draw at the end of each term. So for students who have been submitting work, every lesson you submit, your name goes into the draw. And once you've completed all the lessons and you do the culminating activity or the test, then your name will be entered into another different draw. So you have lots of chances to win prizes. Okay, so that's it for the announcements this morning. Let's get started, or actually we'll review what we did in class last day or what we've done so far. And then we're going to move on to looking at fractions today. So far, we've been talking about last week, and in our class on Tuesday, we've been talking about integers. So there are rules for adding, subtracting, multiplying, and dividing integers. Now, it's very important that you don't get the rules mixed up, because then you end up with obviously the wrong answer. So the integer rules for adding adding integers. So if you're adding integers that have the same sign, so they're all positive or they're all negative, then you're just going to add the numbers and take the sign of the numbers you're adding. So for example, a -3 plus a -4, both of the numbers are negative, so your answer will also be negative, and you just add the numbers. 3 plus 4 is 7. With a +3 and a +7, this is your basic addition. So you just add the numbers. 3 plus 7 is 10. Okay. If you have more than two numbers, so let's say you had a +3 plus, -3 plus a -1 plus a -7, same thing. Okay. All of the numbers are negative. So because all of the numbers are negative, then your answer will also be negative. And then you just add the numbers. 3 plus 1 is 4, plus 7 is 11. So your answer is -11. Same thing with positive numbers. If you have a positive plus a positive plus a positive, then your answer will be positive. Okay, so that's for integers with the same sign. Excuse me. If you're adding integers with different signs, so you have some of them, one integer is negative, one integer is positive, then it's a little bit different. So in this case, what you have to do is subtract the integers, and then you use the sign of the largest absolute value. So in the example, -5 plus +9, we've got a negative integer and a positive integer. So we're going to subtract the numbers. 9 take away 5 will equal 4. But is it a +4 or a -4? So in this case, we have to look at the absolute value of the number. So the absolute value, remember, means the value of the number without the sign. So the absolute value of -5 is 5. The absolute value of a +9 is 9. So then we look at which number has the larger absolute value. In this case, it's 9. 9 is positive, so our answer is positive. Okay, -13 plus -8. So again, we're going to subtract the numbers. 13 take away 8 gives me 5. But now I have to determine the sign of that 5. Is it a +5 or a -5? So again, I look at the absolute values. Absolute value of -13 is 13. Absolute value of +8 is 8. So 13 is bigger than 8. 13 is negative, which means my answer will be negative. Okay, so with the same sign you're adding, it's easy. Keep the sign. But with a different sign, it's a little bit more tricky. You have to take your time, look at your integers, and subtract. Even though we're doing addition, you're going to change it. You have to subtract to find the value of the number. So what is the number going to be? And then you have to look at the absolute values of the numbers to figure out what the sign is going to be. So you got to do two things there, basically. Subtracting integers. When we subtract integers, we're technically not subtracting integers. Okay, it's a little bit tricky because what we do when we're subtracting integers is we change the subtraction into an addition problem. Now, we're not just taking subtraction and changing it to addition and then adding the numbers. Okay, we have to make two changes. The first change is to change your subtraction to addition. The second change involves the number that's being subtracted. So then what we're doing for the second change is we're changing the number that's being subtracted to its opposite. So in -3 take away +4, the first number, -3, stays the same. Then we change our subtraction to addition, and then we're changing the +4 to the opposite, which is -4. So we end up with a -3 plus a -4, And then, because we've changed it to addition, now we use the addition rules. So we've got a negative plus a negative, so our answer is going to be negative, and 3 plus 4 is 7. Okay, for a -5, take away -9. The -5 stays the same. Then we change our subtraction to addition, and then we're changing that -9 to its opposite, which is +9. So now we have a -5 plus a +9. So we use our addition rules. When the signs are different, like here, -5 and a +9, we subtract the numbers. So 9 take away 5 equals 4. Now we look at the absolute value of the numbers, 9 and 5. 9 is bigger than 5. 9 is positive, so our answer is going to be positive. So it's +4. Okay, so addition, same sign, just add the numbers and take the sign of the numbers. If the signs are different, then you're going to subtract the numbers and take the sign of the largest absolute value. When you're subtracting, we're going to change it to addition by changing subtraction to addition and then changing the number that we're subtracting to its opposite. And then we follow the addition rules. Okay, multiplying and dividing has, as I mentioned, different rules. So for multiplying and dividing integers, if the numbers that you're multiplying or dividing have the same sign, then your answer is going to be positive. So if you've got a negative times a negative, your answer is going to be positive. If you've got a positive times a positive, your answer will also be positive. If the signs are different, whoa, let's move that back to where it was. If the signs are different, then your answer will be negative. So if you've got a negative times a positive, your answer is going to be negative. If you've got a positive times a negative, your answer is going to be negative. Okay, so again, watch out for your rules. Don't mix up your addition and subtraction rules with your multiplication and division rules. So we'll do a couple examples here, and then we'll move on to fractions. Okay, so these are all mixed up. We've got addition, subtraction, multiplication, and division in here, so we really have to watch the signs. So the first one is addition. So we've got a -5 plus a -4. Both of them are negative. We're adding, so my answer is going to be negative. 5 plus 4 is 9. Okay, pretty straightforward. Okay, the next one is, we'll go down this column here. So -3 plus +1. So we're still adding, but this time we've got different signs. We've got a negative and a positive. So first thing we do is subtract our numbers. 3 take away 1 is 2. Then we look at the absolute values. We've got 3 and 1. 3 is bigger. 3 is negative. So my answer is going to be -2. Okay, next one, we've got -2 times -7. So this time we're multiplying. It's a negative times a negative, so same sign, which means my answer is going to be positive, and 2 times 7 is 14. The next one is a +3 times -1, so now I'm multiplying again. I've got different signs and positive times a negative, so my answer is going to be negative because the rule tells us if the signs are different, we end up with a negative answer. 3 times 1 is 3, so my answer is -3. And the next one, we've got -3 plus +9. We're adding this time. So because I've got a negative and a positive, I'm going to subtract. 9 take away 3 is 6. And I got to look at the absolute values of my numbers, 3 and 9. 9 is bigger than 3. It's positive, so my answer is going to be +6. Okay, the next one, the next column, we've got -4 times a -7. So I'm multiplying this time. 2 negatives will give me a positive. So -4 times -7 is going to give me a positive answer because the signs are the same. 4 times 7 is 28. Next one is -18 divided by -6. So we're dividing this time. both negatives, so my answer is going to be positive. And then 18 divided by 6 is 3. Okay, so you got to really watch the signs when they're mixed up like this. Next one is positive 8 times a positive 3. I'm multiplying now. 8 times 3 is 24. And they're both positive, so my answer is positive. The next one, we got negative 4 take away negative 1. So the rule tells me I got to keep the first number the same, change subtraction to addition, change the number I'm subtracting to its opposite. So now I have negative 4 plus negative 1, and now I'm going to use the addition rules. Subtract, 4 take away 1 will give me 3. 4 is bigger than 1. It's negative, so my answer is negative 3. Next one, we've got negative 5 times positive 3. So now I'm back to multiplying. The signs are different, so my answer is going to be negative. 5 times 3, 15. So the answer is negative 15. Next column, we've got positive 6 minus negative 2. So I'm subtracting. So I have to rewrite this as an addition problem. So I've got two negative minus signs, or a minus and negative. So that's going to be plus right away. So remember I told you before, shortcut. If you see two negative signs together, then it's positive. So I've got a positive 6 plus a positive 2, which will give me positive 8. Now I'm back to multiplying. Negative 1 times positive 5. Got a negative times a positive, which means that my answer is going to be negative. 1 times 5 is 5. Excuse me. Positive 9 plus negative 3. I'm adding now. I've got different signs, positive plus a negative. So I subtract my numbers first. 9 take away 3 is 6. 9 is greater than 3. Absolute value, it's positive. So my answer is going to be positive. Next one, positive 6 plus negative 5. I'm adding. I've got a positive and a negative. So I have to subtract first to get the number part of my answer. 6 take away 5 is 1. Then I look at the absolute values of the numbers, 6 and 5. 6 is bigger, it's positive, so my answer is going to be positive 1. And then the last one, I've got negative 3 divided by a positive 3, so I'm dividing this time. Signs are different, which means my answer is going to be negative. 3 divided by 3, is 1. So negative 1. Okay, so those are the rules, for adding and subtracting integers. Basically, like I said, you just have to remember them, and then you have to practice doing problems with them so that you do remember the rules and you don't have to look them up every time. All right, so we are now done adding, subtracting, multiplying, and division of integers. So now we're moving on to working with fractions. So today we're going to talk about fractions, different types of fractions, and some changing fractions. So in your lesson, beginning on page 17, not 17, yeah, 17, sorry, is an explanation of what fractions are. So if you're not quite sure about fractions, I mean, most of us have seen fractions at some point, so we have an idea of fractions, but fractions can be tricky. So read through this information on page 17 that explains what fractions are. Page 18 talks about changing improper fractions to mixed numbers, and support question 5 is there. Make sure you do that support question. Then on page 19 is changing a mixed number to an improper fraction, and support question 6. So make sure again that you do that support question. Then on page 20 is information on what equivalent fractions are, which brings us into reducing fractions. So read through that material and do support question 7 before you attempt the key questions. Okay. So let's start off with some information on what fractions are. So we know that a fraction is a part of a number. It's not a whole number. So when we were talking about integers and we talked about negative numbers, we talked a little bit about fractions. So a fraction is a part of a number, but it's not less than 0. So a fraction occurs between 0 and 1, 1 and 2, 2 and 3, etc. Okay, so it's a part of a number. So a fraction has two parts. It has a top part, okay, in this case, the fraction half. The top part is called the numerator, and it tells the number of equal parts taken or equal parts left, depending on how you look at it. Then we have the fraction bar, okay, the line that separates the top number from the bottom number. The bottom number, in this case 2, is called the denominator. So if you can't remember which one is the numerator, which one is the denominator, just remember that the 2 is down below the 1 and denominator starts with a D. Okay, that's one way of remembering it. So the denominator tells the total number of equal parts in a whole or collection. Okay, so what are fractions? Fractions can represent equal parts of a whole or a collection of something. So if we're talking about fraction of a whole, so that means a whole watermelon or a whole apple or a whole donut or something like that. So when we cut up, so for example, a watermelon into equal parts, so when we're talking about fractions, they have to be equal. Each part is a fraction of the whole. So we have here a whole watermelon. If we cut the watermelon into 2 pieces, okay, slice it right down the middle, we end up with 2 equal parts that are half. So we've got a half on top and a half on the bottom. So we've cut the watermelon into 2 equal pieces. If we take those 2 pieces and we cut them again, then we've divided our watermelon into 4 equal pieces, and each piece is 1 of the 4. So that's where our fraction comes in. So the bottom number, the denominator, tells us how many pieces we cut the watermelon into. We've got 4 pieces. The top number tells us what each piece is. So 1. So the first piece is 1 of the 4, the second piece is 1 of the 4, the third piece is 1 of the 4, and the fourth piece is 1 of the 4. So there's 4 equal pieces, and each piece is 1 of them. Now, if somebody comes and eats 1/4, one of those 4 pieces, we are left with 3 equal pieces. So now we have 3 of 4 left. So that fraction is 3/4 or 3/4. Okay, because if you think of fourth, there are special names for some of the fractions. So for example, 1/2 is a half. 1/4 is a quarter. So just like 4 quarters in a dollar, that's the idea here. So 1/4. Okay, so for when we're talking most fractions, we will say 1/3, 1/8, 1/9, whatever. So you use the ordinal value for the fraction. So thirds, fourths, we could use a quarter, or we could use fourths, fifths, sixth, seventh, eighth, etc. Okay, so that's a fraction of a whole. We can also have a fraction of a collection. Okay, so in this picture, we have a group of animals, a collection of animals. That could be the pets that belong to one person. So we can look at this picture, and in this group of animals, we can answer the question, what fraction is cats? So if we look, we've got 1, 2, 3 cats. So 3 of the collection, there's 5 pets there all together. So 3 of the 5, 3/5 are cats. Okay, we can also answer the question, what fraction is dogs? We've got 1, 2, so 2 of the 5 are dogs. So 2/5 are dogs. Okay, so you can have a fraction of a whole or a fraction of a collection. Fractions on a number line. So as I mentioned before, we can fractions occur between 0 and 1. So we can represent them on a number line. All we have to do is divide the number line into equal parts. So if we divide the number line from 0 to 1 into 2 equal parts, then our fraction is a half. It's halfway between 0 and 1. If we divide our number line into 3 equal parts, then we have first part is 1/3, the second part is 2/3, and the third part would be 3/3 or 1. Same thing. Okay, we can divide our number line into 4 equal parts. So we have 1/4, 2/4, 3/4, and at 1, that would be the same as 4/4. Okay, same thing we can do with fifths, sixths, eighths, tenths, whatever number you want. So you would divide it into that number of equal pieces. So we've got 1, 2, 3, 4 equal pieces. For fifths, we've got 1, 2, 3, 4, 5 equal pieces. For eighths, we've got 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. And they're not actually equal, but they should be. Okay, so those fractions on a number line. Okay, a few more examples. So here's an example of a whole circle. We'll say it's an orange being cut into 2 pieces. So half of the orange is yellow in this section, or sorry, half of the orange is left. We've got a quarter, 1 of the 4 pieces left. And in the next one, we've got 3. Okay, 1, 2, 3. 3 of the 4 pieces are left. So that's how you represent a fraction. Or in the first one, we could say a half of the fraction is missing. Okay, in the second one, we can say 3/4 is missing. And in the last one, 1/4 is missing. So it depends on how you want to represent it. Some real life examples of fractions. So the most common examples are equal slices of pizza, equal slices of fruit, cake, bar of chocolate, whatever. Some non-examples, so some examples of pieces of objects that are not fractions because they don't, they're not even. So in this first example of the pizza, these are not even. They're not all the same size, so that would not be, you wouldn't be able to use that a fraction to represent that. Same in these shapes here, they're not divided evenly, so we couldn't use fractions to represent the amounts. Okay, we would have to divide them up evenly in order to do that. All right, so mixed numbers and improper fractions. So what is a mixed number? A mixed number is a number that's made up of a whole number and a proper fraction together. For example, the number 2 1/3 is a mixed number because we have a whole number, the number 2, and we have a fraction 1/3. So if we wanted to draw pictures to represent that, here's 3 circles. The first 2 circles are whole. Everything is there. In this third circle, only 1/3 of the circle is left. So we have 2 wholes plus the fraction 1/3. So that's 2 1/3. You could also represent this on a number line. Okay, so 0, 1, 2, 3. So our 2 wholes would be from 0 to 1 and 1 to 2. And then the next one from 2 to 3 would have to be divided into 3 equal spaces and 1/3. So if you wanted to represent this on a number line, this is where 2 1/3 would be. Okay. So mixed numbers are sometimes called mixed fractions. So you'll hear me say mixed numbers and you'll hear me say mixed fractions because they're the same. So what is an improper fraction? So an improper fraction is a fraction where the numerator is greater than or equal to the denominator. So in the example of 7/3, this is an improper fraction because the number on the top is greater than the number on the bottom. So the numerator 7 is bigger than the denominator 3. You can see the improper fraction 7/3 below. So right here, we're talking improper fraction 7/3. Each circle is divided into thirds. And 7 of the thirds are still there. So 1, 2, 3, 4, 5, 6, 7. 2 are missing. So with each divided into thirds, we have 7 thirds. But we can also look at this as 2 wholes and 1/3. So an improper fraction can also be represented as a mixed fraction or a mixed number. So improper fractions are sometimes called top heavy because the top is bigger than the bottom. Okay, so we can convert a mixed number or mixed fraction to an improper fraction and vice versa. So the mixed fraction 2 1/3, as I mentioned, and the improper fraction 7/3 are actually the same. They represent the same amount. Mixed numbers and improper fractions should show the same amount. So as I mentioned above, here we've got 2 1/3, but it's also 1, 2, 3, 4, 5, 6, 7 thirds. Because each of those circles is divided into 3 pieces. So let's say you have a mixed number and want to write it as an improper fraction. So this is something that you're going to need to know how to do when you're working with fractions, especially when we want to multiply or add, subtract, multiply, or divide mixed numbers. So to change a mixed number to an improper fraction, this is what you do. First of all, multiply the whole number by the denominator. So that's the bottom number on the bottom. Second, add that number to the numerator. We add. And then the third is write that sum on top of the original denominator. So to change 2 3/4 to, it shouldn't say to a mixed number, it should say to an improper fraction. So first, multiply the whole number, which is 2, by the denominator, which is 4. 2 times 4 equals 8. Then add that number, 8, to the numerator. So our numerator is 3. So 8 plus 3 is 11. Now write the improper fraction. So that becomes our numerator over the original denominator, which is 4. Excuse me. So again, multiply the whole number 2 by the denominator, which is 4. So we get 8. Then we take that number and we add it to the numerator of the fraction, which is 3, which will give us 11. And the improper fraction is 11/4. Because we always keep the original denominator. Okay, so let's do some practice. So 6 1/8 as an improper fraction. Take the 6, put it down here, multiply it by the denominator, which is 8. 6 times 8 is 48. Add the numerator to that number. So 48 plus 1 equals 49. 49 is the numerator. The denominator is the original number, which is 8. So 49 eighths. For number 2, 19 quarters. These are pretty big numbers. So the whole number 19 times the denominator 4. So 19 times 4, 76. Take the number 76, our answer, add it to our numerator, which is 1. We end up with 77. 77 is the numerator of our fraction. The denominator is the original denominator. Number 3, 5.5. Whole number 5 multiplied by denominator 2 is 10. Take that 10, add the numerator 1, gives us 11. Our numerator is 11. Denominator stays the same, so 11 halves. So it doesn't matter what your fraction is. 12 and 4/5. Whole number times denominator, 12 times 5, 60. That's 60 plus 4 equals 64. That becomes our numerator, sorry. Denominator stays the same, so 64/5. One and 1/6. Whole number 1 times denominator 6. Take the 6, add numerator 1, 7. 7 now is our numerator. Denominator stays the same. 4 and 7/8. 4 times the denominator 8 equals 32. 32 plus the numerator 7 is 39. 39 is our numerator over the denominator that we started with, 8. Okay, so that's how you change a mixed number or mixed fraction into an improper fraction. As I said, you need to know how to do that when we get into operations with fractions. Okay, so now to do the opposite of that, to change an improper fraction to a mixed number. So to change an improper fraction to a mixed number, we're going to do basically the opposite. So step 1 is divide. Divide the numerator by the denominator. Step 2, write down the whole number, part of the quotient. And step 3, take the remainder and write it over the original denominator. So to change the improper fraction 9/4 into a mixed number, first we divide. So 9/4 means 9 divided by 4. If you do 9 divided by 4, you get 2 with a remainder of 1. So you can do this using your calculator, but if you use your calculator, you'll get what the whole number is, but you won't get the remainder. You'll get a decimal. We're not changing improper fractions to decimals. We're changing improper fractions to mixed fractions or mixed numbers. So we need a fraction and a whole number as our answer. So 9 divided by 4. You can use long division. Okay, 4 divided into 9. 4 times 2 will give me 8. 9 take away 8 will give me 1. And here is my remainder. So I get my whole number 2, my remainder 1. So then you write down the whole number, which is 2. The remainder becomes the numerator of our fraction, and the denominator stays the same. So 9/4 is the same as 2 1/4. So what if there's no remainder? So that means your answer is a whole number. So 12/4, for example, we've got our squares, I guess, our diamonds, whatever, are divided into 4 equal spots, equal pieces, sorry. So our fraction is fourths. And we have 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that gives us 12/4. To divide, 12 divided by 4 gives us 3. There is no fraction. Because there's no remainder. It divides evenly. So our answer is just a whole number. Okay, so we'll do a couple of these because we are out of time. Okay, so convert 113/12, 113/12 to a mixed number. So what do? 113/12 is the same as 113 divided by 12. So 113 divided by 12, if I use my calculator, my answer, my whole number is 9. So I get the answer 9.416. It's a repeating decimal. So my whole number is going to be 9. To find out what my remainder is, I'm going to multiply 9 times 12, which gives me 108. So now I'm going to do 113, take away 108. I can do it on my calculator, but I have to do it differently. Equals 5, so my remainder is 5. So my fraction is 9. My fraction is 5/12. So my answer is 9 5/12. Now I can do long division. 13, not 13, sorry, 12 into 113. So 12 divided into 11 won't go. So I have to divide 12 into 113. So I know it goes 9 because I already did it. So 9 times 12 is 108. 113 take away 108 leaves me with 5. So there's my remainder. Okay. So the second one, 19 halves. So 19 divided by 2. Well, I know that 2 times 9 will give me 18. So my whole number again is going to be 9. 19 take away 18 will give me 1. And my denominator stays the same. So 9.5. Okay, so you can use your calculator, you can use long division, or you can do it in your head if your math is pretty decent. So 36/10, 36 divided by 10. 36 divided by 10 is 3, because 10 times 3 is 30, and I have 6 left over. So 3 6/10. Now, actually, we'll just leave that like that because we haven't done the next step yet. So the next thing we're going to be looking at is reducing fractions. So that 6/10 can be reduced, but we're not going to worry about that right now. Okay, let's skip down here to 13 divided by 3. I know 3 times 4 is 12 with a remainder of 1. 13 take away 12 will give us 1. And my denominator stays the same. So 4 1/3. 39/4. So 39 divided by 4. 4 times 9 is 36. 4 times 10 will give me 40. So that's too much. So 39 take away 36 is 3. So 9 3/4. 68/10. So that's 68 divided by 10. 10 times 6 will give me 60. And then there's 8 left over. So 6 8/10. Okay, and that can also be reduced. Number 10, 27 divided by 5. 5 times 5 will give me 25. 27 take away 25 gives me a 2 left over. So 5 2/5. 53 eighths. So 53 divided by 8. 6 eighths are 48, 7 eighths are 56. So 6 eighths are 48. 53 take away 48 is 5. So 6 and 5 eighths. 72 divided by 10. 10 times 7 is 70, with 2 left over to 2/10. And this fraction can also be reduced. Some can be reduced, some can't. If we can reduce them, we will. But we'll look at reducing fractions in our next class. So for today, you're going to look at key question 5. Change the following improper fractions to mixed numbers. So 5/4, 25/4, and 57/4. You change them to mixed numbers. So your answer will have a whole number and a fraction. So 5 divided by 4. Okay, so 5/4 means 5 divided by 4. 4 divides into 5 once, which is 4. 5 take away 4 will give me 1. And the remainder is, 1, and the denominator stays as 4. Don't change your denominator. Okay, so do the same thing for the other ones. 25/4 is 25 divided by 4. 57/11 is 57 divided by 11. So you need a whole number and a fraction. Now, number 2, change the following mixed numbers to improper fractions. So we're going the opposite way. So remember, whole number times denominator. 4 times 8 is 32. That answer plus the numerator equals 35. The 35 becomes the numerator of the improper fraction. The denominator stays the same. So 35/8. Okay, so take your time doing those. Remember to do it step by step. Don't try to rush it, because then you're going to make mistakes. Okay, so that is it for our class today. Thanks for joining me. And next week, we will continue on working with fractions. If you have any questions, please contact me. Other than that, enjoy the rest of your week. Miigwech.